Welcome back. In the last parts of this tutorial, we generated our terrain and we added some additional attributes, including the ambient occlusion. In this part of the tutorial, we're actually going to start to use these attributes. So let's start off with a method that you might be familiar with. Because we have all these attributes, and we can basically make groups based on them. So that is what we're going to do. So if we would make, for instance, a group expression, we could start to make a group. Of all the steep parts of the terrain, for instance. Or we could do the opposite and say we want a group for all the flat areas. And this approach generally works. But for the method we are going to use, we actually want to make sure that there is no overlaps between the groups. And to actually enforce that in group expressions requires quite some vigilance, let's say, to make sure that you keep track of all the expressions and make sure that they don't overlap. So instead of groups expressions, we're actually going to create a splatting map of sorts. So first off, I'm still going to start with a more hard-coded approach. So I'm actually going to store what the current biome is in an integer attribute. So that would be I at, and in this case, I'm actually going to start the attribute names with underscores. It might become more obvious later why I do that. Okay, so first I'm going to give it a default value. And I'm also going to use a color node to actually visualize the biome. So we're going to do a random from attribute in this case. I'm just going to copy paste the attribute in here. And now we should have a flat color because all the biomes in this wrangle node are the same. So if I would start to add expressions like this, say if slope 0.5 and underscore biome index would be 1, and then we can say else if slope is smaller than 25, biome index is 2, then we can make third group ambient occlusion, then the biome index is 3. Okay, so now we have non-overlapping biomes, because every point can only have ever one value of this attribute. So there's no chance that the biomes will overlap. But this if else if structure is quite limiting, because you have to generate quite a long piece of code, and then it does become unreadable if you keep adding more and more biomes. It's actually one thing I'm still going to add. Oh. So I'm going to add a string attributes underscore biome name equals none. And in this case, it would become slightly more easy to actually keep track of the biomes, because then at least you can see in the code which condition belongs to which biome. But yeah, you still generate a quite restrictive system this way. So what we're actually going to do is actually expand our biome system outside of Houdini. And we're going to use an external file to actually control this generation inside Houdini. So for that, I'm actually going to use OpenOffice. You can use Excel or Notepad, Notepad++, whatever you prefer, or a more specialized CSV editor, because we're going to actually save these files to a CSV in the end. Okay, so what we're actually going to do is put, actually going to minimize Houdini a little bit. We can have them side by side. And actually start specifying these attributes inside the CSV file. So I'm going to first put biome name. I'm actually going to use headers in this CSV file. You could also choose to make the CSV file without headers, but personally I do prefer being able to see at the top what each color means, each column means. And for after the first two, I'm just going to put all the attributes that we actually have generated. I'm actually going to use middle mouse button click to see some of the other attributes. For instance, mesa, and cliffs, which actually come from the erosion generation, which are going to include as well. Oh yeah, also don't pay attention to this yet, and I just added it already. Going to add something we go to play with later. And actually, I'm trying to make sure that I name the attributes the same way as I'm naming the attributes themselves in the CSV file. I'm going to add a water. So let's add some biomes. Occluded, open, and cliffs. I'm just going to put the weight to 1 for now. And for occlusion, if it's 0.5 or higher, then we're going to say it's occluded. If it's 0, it's probably going to be open. And for cliffs, we don't really mind what the occlusion is, so I'm just going to put it in between. And for slope, I'm going to put 0.5 everywhere, except for cliffs. So basically, a higher value will make it more likely, in terms of slope, that the biome will be a cliff in the end. For mesa, actually, we're not really using them right now. And cliffs, actually, I'm going to add 25 here as well. Because cliffs is not a super reliable attribute from the erosion, but you might as well use it. Okay, so water needs to be 0 as well. Okay, so we're going to save this file as a CSV file. I'm going to add, call this Biomes. Okay, so yes, we're going to keep the current format. And in this case, we need to make sure that we put the delimiter at semicolon, and text delimiter we can keep as such. We're going to put the character set. I think it should not matter. Yes, okay. Because sometimes if you're in Western Europe, it might convert all your decimals to commas. So you actually need to set it up in the settings of either program that you're using. Okay, I'm going to save that. And now we're actually going to go back to Houdini. I'm going to leave the window like this for a little moment. I'm actually going to use the table import. So the table import is actually a built-in CSV loader for Houdini. And we can now select the biomes file here, which will be hip/biomes. And that should generate 3 points, because right now we have 3 entries here. Because Houdini is smart enough to realize that the top is actually a header. Sometimes it might not realize it. For instance, if your first column is not a string, so you might need to refresh it, or actually just use a last node and just set this to 0 and set this to points. So this way it would delete the first entry. So you can also fix it like that. Okay. So now we would need to actually make sure that all these attributes match again. So I'm actually going to put Houdini right here. And we can see that we have 5 attributes. So I'm going to say 5 attributes. And we're going to put column 0. No, this is going to be column 0, 1, 2, 2. Attribute length is 1. Going to be 3. Attribute length is 1. Wait, this is 3. is this is 1, this is 4, this is 1, 5, and this is okay. I think I added one too many then. Okay, so these are all going to be floats. This one is going to be occlusion. Actually, because we named our attribute ambient occlusion, I'm actually going to go back to inside that node, and actually going to rename our ambient occlusion to simply occlusion, because that will save us some typing later, and also less chance of mistakes when typing it out every time. Have to make sure that we change it everywhere. No, lab. Zero, comma 1, and occlusion. Okay, there's actually also one thing you can do if you're working with subnets, is using a output node. Which will always force the output of the node to be the node that is the output. This is a safety mechanism. So if you dive in a subnet and then set the render flag to, say, an arbitrary node, if you go out and forget about it, then all the nodes underneath don't cook. But if you add an output node, that there is no chance that that happens, because the output is always the output. So in that case, you are allowed to forget about it, and your network will not break. So just to check if our ambient occlusion still works. Okay, let's save again. So yes, it all still works. And also going to rename this to occlusion just to be complete. Okay. So now, yeah, we can go back to the file again. So we have occlusion, we have slope, we have mesa, we have cliffs, and we have water. Okay, I think it seems so 0, 1, 2, 1, 2, column 3, column 4, column 5. Yes, and column 6. Yes, that seems about right. Okay. So now if we go to the geometry spreadsheet, we can see actually like this. We can see that cliffs, mesa, and occlusion all match values that are in here. But in this case, it's probably a very good idea to also actually add the biome name. So column 0 is going to be a string, and it's going to be biome name. Yes, okay. So now we can see that occluded matches for occlusion. And if I actually specify, I actually want to sort it by points, so this way it should be exactly the same as we specified here. Okay, so that's all taken care of. So what we actually want to do now is do some clustering. And this is going to be done again with some VEX code in a wrangle. Because what we're actually going to do is go through the entire list for every point and actually check the difference with the target biome. Okay, so this is going to be some more advanced facts, I would say. So first off, we actually want to check how many biomes there could possibly be. So that would be int node biomes, which equals the amount of points in the second input coming from the table import. We're going to generate some attributes, some more variables. I'm going to create an array attribute. I'm going to add a float self value and other value. And we're going to resize the array and list sums by the amount of biomes that we have. Okay. Then we're actually going to make a string array attributes in which we will specify all the attributes that we want to check against. And theoretically, what I could do is make another multiparm or like a string parameter to fill in manually which attributes to check. But instead, I'm actually going to just check in the detail intrinsic which attributes actually exist in the biomes. So this will actually generate this string attribute as string array filled with these values. So if I would print that out, if enum equals 0, it's always a safe way to make sure that you don't print the debug for every point. So printf modulo d to output an integer attribute. Modulo s to make a string or string array. And now if we cook it, yes, we actually get all the attributes. And now you actually see why I added the underscore. Because in the geometry spreadsheet, the names of the attributes are always sorted by name alphabetically. So first off, you will always have the position, and after that, it will be alphabetical. So because an underscore is very much at the beginning of the alphanumeric searching, it's a good way to make sure that whatever you want is at the start. And the rest actually also matches the same order. Okay. Don't need that anymore. And we're actually also going to store the amount of attributes, which will be trips, just the length of the array. Okay, that all still works. Actually, I'm going to use Alt-E to make the window bigger. So now we actually want to go through all the point attributes and check the difference of the terrain with the source from the CSV file. So we're going to do this with a for loop. So normally what you would do is for int I equals 0, I is smaller than num attributes I plus plus. In our case, we actually want to skip the position, the position and the biome name. So that would be 1 and 2. Yes. So now it should start at cliffs. The P will be 0, biome name will be 1. We will get the self value, so S value will be a point attribute from the first input, and we're going to fetch from the array the name of the attribute and the current point number. Normally you could use a bind to do this, but a bind doesn't allow you to actually fetch the attribute name from a string. So we're actually going to use the point function in this case. And then I'm actually going to go again in a for loop for int j is 0. J is smaller than the number of biomes. Actually, I'm going to quickly do that. J plus plus. Okay. And we're going to get the other value, which will be the same as this, but from the first input. And in this case, it is important that we name the attributes in the CSV file the same as in the terrain. That will make everything a lot more easy to deal with. Okay, so first we're going to actually subtract the other value, subtract from the other value the self value. So this way we'll actually have the distance, or the difference. But to get the difference, the distance, let's say, we actually need to square this value. Think of Pythagoras, if you are wondering why I'm doing this. So basically, if you want to have the distance or the length of a of the angled side of a triangle, of a right angled triangle, you make the square of the bottom and the square of the height, and then take the square root to get that. But if we actually would go beyond that and make another, like a triangle in 3D, you would do another Pythagoras. But for the theory, it actually doesn't matter like in how many dimensions you do it. So if you just keep actually multiplying the value with itself to square it, you can add as many dimensions as we like. And in our case, the amount of dimensions is just the amount of attributes that we check. So that was a lot of maths. I hope you were able to follow that at least a little bit. But otherwise, the code will work regardless. So what we're going to do is actually add this value to this array. So and just sums. And we're going to check for the current biome, which is J. We're going to add the O value. Okay, so now that should tell us the compute, hopefully. It does. And now we can actually use another function, which is argsort, which can generate a index array to sort the distance array. So sort r ix equals argsort and dist sums. Okay, so what we now just need to do is pick the first index of this array, which will point us to the lowest value in this array. So if you actually want to fetch the name as well, we can do that. So string found biome equals 0.1. And we actually have this name in the array as well, which is going to be attribute 1, because attribute 0 is going to be position. Genome. Is no, wait, that's not what I meant. That's the next line. And that's going to be sort r idx 0. Because the first index of this array will point to the index of this array where the value is the lowest of the array. And then we actually want to, set this information to our terrain as well. So we're going to add a set point attrib 0. And in this case, we actually want to again use the attributes 1. going to write it to ptnum, and we're going to push found biome. And we also are going to copy this and make an extra attribute, which is going to be biome index, because certain functions later are better with dealing with integers than strings. So we're just going to actually use the integer of the array again to write to the biome index. Okay, so if that all works, what we can do now is actually put a color here. Okay, so it doesn't work just yet. Now we need to figure out why. Okay, so if I go to geometry spreadsheet, yeah, we can now see that the biome name is occluded for all these values. And we can do a simple test. Okay, so if we take a flat area here, say zoom in a little bit, and simply type over this number, so 597484, for instance. Yes. So now the wrangle will actually only execute for this point. It doesn't need to be the same point. That's not really important. But now we can actually start to do our debugging. So for instance, I could just print f modulo d \n. So whenever you're printing, it will print it to the next line. Otherwise, you'll get all the debug log on one line, which will become unreadable. I'm just going to return this array. Okay, have to fetch the. Okay, so right now it's actually putting the same value into the array for every point. So what am I doing wrong? Ah, yes, of course. This needs to be j, because we actually want to go through all the biomes and fetch the point number from there. So now we actually have different values. Okay, great. So comment that out. Visualize. Unfortunately, the code doesn't work just yet. Oh wait, that's maybe because I'm only executing from this point. Okay, that's not the problem. Okay, so I'm executing just for that point now. Okay, let me watch that again. So basically that should, say the distance to occlude it is this much, to open is this much, and to close is that much. But because this value is the lowest, it should actually be open. So the arcsort doesn't work exactly as expected. So I'm just going to Ctrl X, Ctrl V, and print this value instead. Okay, keeps putting. Yes, that's what I would expect. So so yeah, this should be returning 1 instead of 0. If I go inside the geometry spreadsheet, it's 0. Yeah, but it should be 1. Why is that? Yeah, that should definitely be 1. So if I would print it like this, it should be returning 1. It does. So in the biome index, it should basically just print that value there. Okay, actually it does work. There we go. And because I was only executing on that point, didn't work. Okay. Yes, now we get different values. So now we actually have all 3 different biomes. And now we just need to see why it doesn't show up correctly. That is why. Yeah, always be careful with attribute names. It's case sensitive. Okay, so now we actually have a very modular system to specify where all these biomes are. I'm actually going to add one more feature in this part of the tutorial. Let's make the window somewhat smaller again. And that's actually adding the functionality for the biome weight. So what we actually can just do, let me quickly check. Yes, okay. So we're just going to do another loop here. Oh yeah, before we actually start to do this, I'm going to duplicate this node, get biome n dimensional. I'm going to copy paste this and make it weighted. So now we actually need to add one more attribute here. That is going to be column 1, going to be again a float, going to be attribute length of 1, and it's going to be biome weight. Go. Go. And to actually check, so right now, if we're in our yes, so we don't have a lot of cliffs. So let's say if we want to make our cliffs more prevalent, we can add a small weight. Make sure that you save the file, and to make sure that you recook the table import, unlock the node. Now we actually might start to see that the system doesn't work anymore. And that is because right now we need to start at attribute 3 because we added one more attribute here. Yes, so this is going to be 0, 1, 2, 3. So we need to start at 3 now. And that also means, no, I think that should be it, actually. Yeah, so now we're actually back to the same result again. So now we can actually start adding the weights. So for int I equals 0, I is smaller than known biomes, I++, we can actually look up the value. I'm just going to say O value is a point attribute. from the biome CSV file, and it's going to be attributes 2, which is going to be the weight, and we're going to go through all the points. We're actually going to add a conditional case. So we're going to say if O value, we actually only want to do this if the O value is bigger than 0, let's say. Then we're going to pick the n-dist sums and divide it by the O value. Because it is basically a distance, so the bigger the weight, the smaller we want the distance. So if we divide it by a larger number, the number becomes smaller. And then for the else statement, we actually want the dist sums to be equal to -1. Now this creates a problem, because with -1 it will actually be always the lowest number, and it will actually return a false biome. So we actually need to make sure that that doesn't happen. So we're going to add another integer, which is going to be biome index x equals to 0. And now we're going to create a while loop. And while biome idx is smaller than known biomes, we want to increase the biome index. Like if you're working with while loops, always make sure that you exit the while loop at the end. Oh, I didn't. Luckily, my Houdini didn't freeze, because yeah, you have to be careful with that. Always make sure that eventually you will go out of the while loop. This is also why I generally prefer to use for loops. But we do not only want to exit the loop when it's at the end of the amount of biomes, but we actually also want to, or basically we want to loop while the biome index is smaller than the amount of biomes, but we also want to keep looping while the n-dist sums let's keep that out for a moment. Actually going to put this above here. And now we actually want to go into this. And that's actually like one of the things you can do with the argsort. And that is put the index of this array inside the other array. So whenever the n-dist sums is smaller than 0, or -1, basically, make sure that we skip this biome and only stop looping while either there's no more biomes to choose from, or when the value is bigger than 0 or bigger. So now instead of that value, we can simply use the biome index, and now all should be well. Okay, apparently it's not. So let's see. If I simply comment out this code, that doesn't do anything right now. Oh wait, of course, yes. I still need to actually use the array. There we go. So now this should all work again. No, this is not. Oh wait, yes. Something. We still have to start at value 3 because I copied it over, but I forgot to change that. So now, yes, okay, now we go. We can do this, and there should be no real difference because we don't have a bio weight of 0. Okay, to demonstrate that this actually works too, we're going to again put the color here. And now we're actually going to change the weights. So if I would put this back to 1, click outside, save, lock, unlock. Don't see much difference. But if I would put occluded on 0, and then start unlocking, yes, there we go. So now there's no more occluded biome because we can simply disable a biome by setting the weight to 0. But if we want to have a lot more occluded, extreme. And it's quite subtle right now. I think I know why. Yes, this needs to be divided equals. Because right now, like, if you specify it like this, it will just do the operation, but it will actually not change this value. If you use divide equals, then this operation will actually be saved to the left side of the function. So yes, there we go. So now basically the entire trade is included. So let's set it to 10. Just using Control S to save. And again, lock, unlock. Yeah, now we can basically start tweaking these values to make sure that we have the biomes that we want. And like one of the advantages that this kind of system has is that if you have a larger team and you only have one person who knows to use Houdini very well, then you can actually still have your other people actually assist with the design because it doesn't require you to use the Houdini interface at all. And you can put this file on a networked hard disk or something, and actually have iterations of your terrain done without even opening Houdini, or at least except on the render farm or whatever you're using. So actually, I do want to increase the amount of weights for the cliff, because right now the cliffs are quite limited. So yeah, so now we have a bit more cliffs. Okay. So yes. I think that covers it for this part of the tutorial. In the next part of the tutorial, we're actually going to improve the table import. Because yeah, you've seen me actually add the attributes using this multi-parm system. And this is quite manageable for 7 attributes. But as soon as you get a lot more, it would actually be nice if this entire system was automated too. And that's actually what we're going to do. Okay, so let's save the file again, and I'll see you in the next part.